So normally machine learning can be categorized into two types: unsupervised learning and supervised learning. Now, unsupervised learning, and the bracket message, highly underappreciated, is actually, honestly speaking, these models are honestly highly underappreciated. People don't use them much. People jump to supervised learning, predictions and stuff. So what do you mean by unsupervised learning? Let's spend some time on that. Unsupervised learning means that you have a data, but you don't have exact target variables. Let me give an example. Suppose you want to predict which customers are not going to be repeat customers for you, predicting churn. But all the data you have is a customer's purchasing pattern, customers' behavior in your shop, customers' browsing behavior in your e-commerce platform. That is it. From there, you're trying to figure out whether someone's gonna leave you or not. Here, we don't have a target variable. We're not trying to predict something. We're trying to predict something, but we don't have a prediction variable there that, a score that we can check and match whether my model score is matching the real-time score. There is no, what we call it, a benchmark, no standard to compare with. So compared to a supervised learning is where you're trying to predict sales. So we have previous sales, and from there we can check how our model is good at predicting sales, and then we can build up on that. Or if you're trying to predict whether someone's going to default or not, if you have past default data, then that also has a target variable. So when you have a target variable and we're trying to build a model to predict that target variable, we call it supervised learning. But when we don't have target variable, then the situation is what we call unsupervised learning. If I give you an example, very recently I'm working with one situation like this. Unfortunately, due to NDA, I cannot name the company I'm working with, but the concern is actually similar to, so it is a retail company where it provides a product which is sold in different retailers all across the country. The company has shared its retailers' performance data with me, and they want to know that at the next month or the coming month, they want to give these retailers some credit. So they want to know that how do you figure out which retailers should be given more credit, which retailers should be given less credit. Basically, the question is which retailer has a chance of giving me the money back, which retailer is not going to give me the money back. Now, I have no previous data, no target variable to compare my model's performance with. I don't know that because these people were never given credits. But from there, I'm trying to get a group of people who I should be giving credits to, who I should not be giving credits to. So this is a classical example of unsupervised learning, where we don't have a predicting, like the variable we are trying to predict. We don't have a target variable through which we are checking our model accuracy. And so one of the biggest challenges of unsupervised learning is it's hard to check how accurate your predictions are. But it also makes it more useful because not every business context comes with nicely designed target variables. So if we look at different types of unsupervised learning, the first and most easiest type is actually something called association rules, or analyzing people's habits. So if you look at the diagram to start with, association rule basically means that, someone is doing X and Y. So based on all our data, we think the next thing that someone's going to do is Z. So a simple example is how Amazon to some extent uses association rules to predict the next thing that you're going to buy. So what they do is they check your buying behavior and they see that, okay, if the person is buying XYZ book, then he or she is more likely to buy ABC book. So in this case, for example, the diagram is showing that someone has bought, so antecedent is like what has been done already. So someone has bought a bread and egg, and based on the data, it's obvious that the next purchase would be milk. So association rule is something, it's very close to recommendation engine, and it's something that is used in Amazon, Netflix, and all other YouTube suggestions, they all use association rules to some extent. Now, when is association rules useful for? When it is a repetitive behavior and we have small data sets. What is a repetitive behavior? That basically means that most people would buy bread and egg, and most people would follow it up with buying milk. So that's a repetitive behavior. But when there is a lot of variation in the data, when there is a lot of outlier in the data, then association rule becomes problematic. It does not, it becomes very less accurate, because it can be that when your data shows, okay, when someone's buying a bread and an egg, one person is not buying milk, one person is buying milk, one person is buying yogurt, another person is buying rice. And if too many variety of data comes in, then the simplicity of association rules don't work, because it's a very simple calculation. So if you see that the database you're using has similar type of behavior again and again, then association rule is one of the most easiest models to apply to make prediction that, okay, what happens if a person does X and Y? What is the chance that the person is going to do Z? A very simple example in this case is supermarket basket analytics. Why? Because in supermarkets, most of the behavior is repetitive. Not many people are going to buy, say, shaving cream and, say, beard groomer. Because normally shaving cream would be followed by rather shaving, shaving kit. So a razor. Then again, if someone's buying beef, the chances are that that person might buy, say, rice or say some seasoning to handle the beef. So there are regular repetitive patterns in supermarket, which is why supermarket and analytics can actually benefit a lot from association rules. Any questions with association rules? Questions, confusions, suggestions, queries, anything? If not, let's move to the next one. The next one is a little bit more complicated. The concept is Kmeans clustering. So this diagram nicely puts the data, puts it in context. So if we have data where there are multiple groupings possible, and if each of these groups are very different from each other, then K-means clustering is useful. If you look at the diagram there, what they're doing is, in the left-hand side is the input. In the right-hand side, they have identified or classified the products into their types. Like in the input, there is a mix of avocado, orange, and apple. In the right-hand side, we have apple, avocado, and oranges separated and stacked separately. So what K-means does, it tries to see patterns in the data and then tries to cluster the patterns together, like similar behaviors together, and different behaviors separate from each other, so that it helps form small segments. So K-means clustering is super helpful when you have large data sets, because these behaviors, they need to find common patterns across these behaviors. So the larger the data set, the more accurate K-means clustering is. And when the groups are not very overlapping between each other. For example, it can be customer profiling, where you're trying to get three groups. So one is rural customer, urban customer, or online customer, offline customer, or age groups. So these are groupings which are very different from each other, or not too much overlap between the groups. If there is not too much overlap between the groups, if you expect the situation, now how do you know this? Because you need to understand where the data is coming from. That's going back to the first advice I gave, that have a good data, which basically means where the data is coming from, and you have good idea of where the data is coming from. And from there, if you understand that these groups are discernible from each other, are very different from each other, should be different from each other, then K-means clustering gives you good results. And that's where K-means clustering is not suitable when the groups are not very separated from each other. There is too much overlap between two groups and their behaviors. Then K-means clustering becomes very messy. A good example is actually customer behavior segmentation. If you want to see different groups of, you'd see that different customers behave differently in your platform, with your product, with your service, and you want to cluster them based in these different behaviors, then K-means clustering can come in really handy. It's a very easy thing to implement, nothing too complicated, and yet it gives you very quick and easy answers. The association rule comes with another big assumption that the association is constant. If the behavior suddenly changes, then association rule is not very accurate at all. K-means is more important because K-means doesn't assume a relationship to start with. The other clustering is called hierarchical clustering. And I actually added the term organogram there because organogram is the best way to understand hierarchical clustering. Hierarchical clustering comes in handy when there is a hierarchy. Basically, for example, this diagram puts it nicely. So initially, say there is a larger grouping, which is the level 3 grouping, which says stuff you can eat or fruits, say. Now, then you have level 2 clustering. Within fruits, we can form 3 other groups. One is large shaped fruits, the top left one, the pineapple and the papaya. Then the medium-sized fruits, kiwi, pomegranate, apple, and orange. And we have level 1, the grapes, small-sized fruits. Then we can actually go one step more. The level 1 is actually each fruit being a cluster in itself. So when we have a data which can be in which has categories, hierarchies in it. For example, geographical sales analysis or major product lines. So for a company, it can, when it's analyzing behavior and analyzing performance, it can look into, say, one major product line. And then from each product line, it can look into single product and its behaviors, or its sales data, or its promotion patterns. So when you have such a cluster there, hierarchy there, then hierarchical cluster comes into play. Or say you're working with regional data, where say you want to first look into the regional behavior, then maybe a sub part of the region, maybe a sub part of the region. It can be in terms of Bangladesh, we can say division, Jela, Thana, this type of hierarchy. And when you're looking at this hierarchy, then hierarchical clustering comes into play. It's not as commonly used as K-means clustering because hierarchical data is not very common either. But if you have a hierarchical data, this thing comes in handy. The last type of unsupervised learning I'm going to cover is actually naive bias. The naive stands for naive. Naivety is naive. That is not too complicated, but it's still not the naive. I mean, naive bias uses a very simple algorithm. What it does, it uses Bayes' theorem. I'm not going to explain statistics of Bayes' theorem here, but the idea is very simple. It tries to classify things or group things based on common patterns in each of the groups. So, for example, this diagram here, naive bias actually is used by Gmail and many other email websites or services to identify spam. What they do is very simple. They take in the email and they're figured out from many emails that, okay, if certain words are there, then it is more likely to be spam. So the naive Bayes model checks the email for these certain words. So for example, I was looking into Google's naive Bayes model a few days back. A friend of mine was showing that. And what Google looks into is certain XYZ words. So like, for example, say newsletter, the word newsletter, or the word sales, if these words are in the email. And then they also check how many people is this email being sent to. If it's sent to mass number of people, then automatically it either classifies it, Gmail either classifies it as in the promotions tab, or it puts it in the spam tab. So naive bias basically uses large data. So one of the prerequisites of naive bias is you need to have good amount of data. When you have good amount of data, and when like you're trying to classify between 2-3 groups, and the properties in each of the group is very consistent. So for example, most spam has sale or money or stuff like that related to it, or opportunity or lottery, these words are always very prevalent in spams. So spam, like anytime these words come up, Google sees them as spam. So consistency among the characteristics of different categories is very important for naive bias to work. So, and an easy example is actually simple fraud detection. What do you mean by simple fraud detection? Say, for example, people are asking for, say, there is, in food delivery companies, people can ask for, okay, I've been given a wrong order. Now, sometimes it can be correct, sometimes it can be wrong. People can send any picture to prove that they've been given the wrong order. How do you identify which is a fraud request from a good request? Simple. You look at that person's history. So they can't actually find out a fraud for the first time, but when they look at the history, they see a pattern coming up that, okay, this person has been asking for this type of problem on a regular basis, and his pictures have this type of messages, or this type of pictures are coming in regularly. And when there is a pattern coming up, the chance is that this person is being fraudulent. Or it can be another way of finding out fraud, could be, say, the request for refund is coming up by one person who's saying he or she is not receiving the product properly, or not receiving the service properly, but his geolocation is changing a lot. So this pattern comes up that basically means that, this is not one person, but multiple person trying to ask for the same thing and earn money in terms of return receipts or return refunds. So these type of simple patterns, if there is a common set of patterns within different categories, then naive bias is very good at identifying them. So these are unsupervised models. Now, one word I'd share with you, if you already have a target variable and you're trying to predict something, that's good. You can just jump to supervised model. But I'm confident that a lot of you in your startups still have not yet had a clear idea of what you're trying to predict or exact target variable, for which these models are quite useful. Just to figure out some patterns, just to figure out from some recurring events happening, just to figure out some small areas where you can get a lot of profit from. So my advice, normally when say I'm approached for a data where there is no target variable, or they just want some exploration with the data, a good work could be look into some unsupervised models. They are also very good at exploratory data analysis. So yeah.
Hello, Van. So would you recommend any tools for doing unsupervised data research?
Well, I mean, tools to komti nahi, but it's mostly if you can code, then there is RStudio, there is Python. If you don't want to code, even then there is a very useful tool. It's actually one of my favorites. It's called Orange Machine Learning. The name of it is Orange ML. So here, let me actually give you a. Sorry, wait. Let me reshare my screen. I'm going to do PowerPoint screen. So this is it. Biolabber Orange ML. I'm actually in USA. I'm a Orange ML use for it. We take the executive education classes here. Orange data mining. It's free and it's quite useful actually. And so another good thing is it uses Python, it's a GUI based on Python. So then if you want to modify these using Python, you can also do that.